Welcome to this explainer. Let's dive right in and demystify the invisible hardware powering pretty much all of our everyday smart devices. Today, we're exploring something you interact with dozens of times a day, probably without even realizing it. We're talking about ROM, or read-only memory, and we're going to break down exactly how it works using some real-world examples. To kick things off, let's just think about a normal day. How does your microwave actually remember what the popcorn button means? Or take your coffee maker. How does it know exactly how to brew that perfect morning cup, even after a massive power outage? I mean, these devices don't have massive hard drives like your laptop, right? Yet, they retain their core instructions perfectly, without any power at all. Well, the answer lies in ROM. This brilliantly illustrates how devices keep their foundational programming safe from basically being forgotten. ROM is a type of non-volatile permanent memory used specifically to store those essential instructions in your electronics. And hey, non-volatile is really just an engineering term meaning that when you pull the plug, the data stays exactly where it is. It doesn't disappear. It essentially acts as the brainstem for your devices. To put that into perspective, standard memory, or RAM, is kind of like a whiteboard. It's super easy to write on, you can change things fast, but it's wiped completely clean the second the power goes out. ROM, on the other hand, is like a permanent printed book. It requires absolutely no effort to keep the words on the page once they're printed, you know? The information is simply there, permanently etched, ready to be read whenever the device needs to know how to function. Here's our agenda for today. 1. What is ROM? 2. The original mask ROM. 3. One-time programmable PROM. 4. Erasing with UV for EPROM. 5. Electrically erasable EPROM. And 6. Modern life with flash memory. Let's start with section 1. What is ROM? It's actually fascinating to realize that without this non-volatile memory, every time the power blinked, our appliances would essentially get digital amnesia. Literally, imagine unplugging your washing machine to clean behind it, and when you plug it back in, it's completely forgotten how to spin, rinse, or drain. It would just be a metal box with a useless motor inside. ROM prevents that. It ensures that those basic, non-negotiable instructions are always waiting right there in the silicon. Now, what's really interesting about the evolution of ROM technology over the decades, moving from MROM to PROM, then EPROM, and finally EEPROM, is that each new iteration wasn't just invented for fun. Each one was actively developed to solve a deeply frustrating limitation of the previous generation. As our need for technological flexibility grew, so did the cleverness of the engineering. Moving on to section 2, the original mask ROM. So these original chips, known as mask ROM or MROM, were strictly hardwired. Think back to the very early days of computing. When a company built a device, the data was physically baked right into the silicon during the manufacturing process using a custom photographic mask. This meant the memory was indeed permanent, which, was the goal, but completely inflexible. If there was a single software bug or a typo in the code, no way to patch it. The chip was totally useless and literally had to be thrown into the garbage. Which brings us to section 3, one-time programmable, PROM. Enter PROM, or Programmable Read-Only Memory. This solved that massive factory bottleneck by shipping as a total blank slate. It allowed electronics developers to program the chip themselves using a special piece of hardware. But here was the catch. You could only write to it exactly once. Inside the chip were these tiny electrical fuses. When you programmed it, you were literally blowing these fuses to create the data pattern. So, once written, the data was set in stone forever. Make a mistake on your one attempt? Yep, the chip went right into the trash. Section 4. Erasing with UV. EPROM. Next up, EPROM. This stands for Erasable Programmable Read-Only Memory. Engineers finally figured out how to erase the ink from our printed book analogy. This was a massive breakthrough because it meant you didn't have to just throw the chip away if you needed to update the code or fix a bug. However, erasing it required a wildly specific physical process. You couldn't just hit a delete key. Erasing these things was a highly manual process. Step 1 required exposing a transparent quartz window built directly into the top of the chip. Step 2, you had to physically remove the chip from the machine and shine intense, concentrated ultraviolet light directly into that window for up to 20 whole minutes. The UV light would dissipate the charge inside the chip, wiping the sleek clean so you could program it again. It worked, for sure, but obviously giving a computer chip a highly targeted sunburn wasn't exactly user-friendly. So, section 5, electrically erasable, EEPROM. EPROM adds another E to the acronym, standing for Electrically Erasable Programmable Read-Only Memory. And guys, this changed the game entirely. By using standard electrical signals instead of physical UV light to clear the data, EPROM made updating your devices infinitely faster and way more practical. You no longer had to pull the chip out of the circuit board. You could just erase and rewrite specific bytes of data electronically while the chip stayed exactly where it was. That electrical leap is exactly what enables the modern world to function seamlessly. Take your computer's BIOS system, the foundational code that wakes your PC up before the operating system even loads. That's stored on EPROM, which is exactly why you can safely download firmware updates at home. It's inside the smart cards in your wallet. It's in your car engine's microcontrollers, allowing mechanics to plug in, run diagnostics, and tweak your engine's software without ripping out a single piece of physical hardware. Finally, Section 6, Modern Life, Flash Memory. Now, you have definitely heard of flash memory, but what you might not have realized is that flash is actually a highly adaptable modern evolution of EEPROM. Flash memory took the electrical rewriting concept of EEPROM and just supercharged it. While older EEPROM erased data one painstakingly slow byte at a time, flash can erase and write data in large, fast blocks. Because of that blazing speed and density, it became the invisible backbone of our daily real-time devices. We're talking everything from our work computers and USB drives to our smartphones and TV remotes. So, to summarize our journey, it's wild to see how the erasure method evolved right alongside our real-world applications. We started with mask ROM, which could not be erased at all, perfect for the rigid, unchangeable code in early arcade games. Then we evolved to EPROM with its 20-minute UV light bath, used heavily by engineers for retro computing prototyping. And finally, we arrive at EPROM and flash, utilizing simple electrical signals. This is what allows things like our modern BIOS and smart cards to update seamlessly on the fly. As we wrap up this explainer, I want to leave you with a provocative thought. If our quote-unquote read-only memory is now so easily rewritable through technologies like EPROM and flash, what permanent secrets will the devices of tomorrow hold? I mean, we've gone from memory etched permanently into silicon to data we can flash and update in a fraction of a millisecond. The boundaries of memory continue to shift, completely changing what our technology is capable of. It really makes you wonder what the permanent memory of the future will look like. Thanks for exploring the hidden brain of your devices with me today. Keep asking questions, and I'll catch you next time.